God damn it, OBS. Okay, I think audio is working now. Yeah. Like, I tried to switch over stuff in OBS so the weird, like, interference from yesterday doesn't happen, but now I have a different problem. Damn it. OBS is weird. Well, I have been just talking into the ether for like, what, 30 minutes. Well, fortunately, nothing amazing was lost. I just written a progress bar thingy that basically you can run and it makes a progress bar. And now I just turned it off, so let me just revert back to this thing and run it. Yeah, it basically just draws a progress bar in the console. Okay. And now I'm trying to figure out how to actually plug that into the other parts of the main that are actually running through the benchmark. Okay. So let's see. Okay, I could do two different things. I could actually count the number of lines in the file, but it sounds a little bit silly to me. Alternatively, if I get a file and I don't know how many puzzles there are, I could just basically have a progress bar like every 100,000 puzzles or something. Okay, so let's just integrate it here because this will be the easy one. So where the heck is it? Right, run benchmark. Yes, okay. And by the way, welcome back. I forgot to say. Okay. So let's create a progress bar here. So the total count will be count. We want to output on ctd cout. And let's make it width 80. Was that the constructor? Yes. Or I guess 79 to just keep it sane. And then after each puzzle, we just do x.step 1. Okay, and let's just see if that works. So if I remove this, rebuild it, conversion, it's complaining about this conversion. Yeah, that's okay. Ah. There's some weird off by one still. What the heck? I thought I just fixed that. We definitely need to do an end line here. Or I guess I can make that part of the progress bar. So when the progress bar is destroyed, just do end line. And then what I can do is I just put this into a scope. And this should, well, not like that, like this. Yep, that works, except for the weird off by one problem. So where the heck is that coming from? Width -1. That should be correct. Yeah, okay. Don't want to spend a lot of time on that today, but it's a little bit weird for sure. Okay, first of all, I thought this was actually what's the name of the file? Yes, and then 0,100,000. Yes, like that. Okay. What the heck is happening? Did I mistype this? No, that's correct. Yeah, I think it like isn't even reading the, yeah. Which is a bit strange. Okay, does it need the absolute path? Oh, no, it's working. Okay, good. Weird enough, here it doesn't seem to have the problem with the off by one. Interesting. Okay, but since I'm done with this thing, and I can actually see if my solver is actually doing something or if it's just stuck, it's time to actually move to the Sudoku solving. So last time I implemented the X chains, so that was the, where the heck is it? Yeah, solve X chains, and those use the get chains method to get the graph. Right. So let's have a look at the other chains. So this was the X chain. Okay. So this one is interesting. It is a chain that only uses bi-value cells, so it's cells that have two possibilities. But the cells have arbitrary candidates. The only restriction is that the XY chain starts and ends with a strong link on the same digit. Okay, so we're looking for a path that starts and ends with the same digit and can only go through cells that have two possible numbers, but it can jump across any numbers. So the graph construction will be different than the X chains, because in X chains we were constructing the graph for two. Yes, we are only constructing the graph for only two possibilities, right? For each number separately. That's what I meant. Damn it. So, okay, let's have a look at this. So we have a 3 here. Strong. So okay, so this is slightly weirdly formulated, because I mean, this isn't actually a strong link on a number, right? This is just that it ends in a cell that has the number as the second possibility. So does this actually work? So if we don't put the 3 here, so then the 9 has to be here, which means that the 8 has to be here, which means that the 2 has to be here, which means that the 3 has to be here. Yes, and vice versa. If the 2 is here, then the 8 has to be here, then the 9 has to be here, and then the 3 has to be here. Okay, so yes. So these are just weak chains all around. The only thing is, this is strangely formulated, but it's not really a strong link. It's just that we end in a cell where the second number is actually the number we are looking at. So I guess when we are actually doing the search, we want to do the search per number. It's just that the graph should be across all the numbers. And only across cells that have two possibilities. Okay, let's have a look at this one. So this is for the number 8. So if the 8 is not here, then the 4 is here. So if the 4 is here, then the 1 has to be here, then the 9 has to be here, then the 8 has to be here, and vice versa. If the 9 is here, then the 1 has to be here, then the 4 has to be here, and then the 8 has to be here. Okay. I think I get it. So how do we want to build this? So I don't think we care about the length in this case. Yeah, because the length, I don't think the length matters at all. But we will want to do it for a particle number. Okay. What the heck? Why is this not working? Okay, so the graph we want to build. Okay. Okay, I think it will be the same data structure, but we want to have it filled with different data. So let's call it get per chains, I guess. And not for a number, because the number in this case doesn't matter. Right. Of squares with two possibilities. Nope. Okay. Okay, so I want to go over all the squares. If the square count possible is 2, then this will be one of my nodes, yes. And okay. So this part will be very different because we want to build up the weaklings, which means that for every node I want to connect it to all the other squares that have one of those numbers. Okay. Yes, so here I will actually go over the nodes I just generated, and for each of them I want to get all the blocks that belong to that square. I should have a method for that. So No, okay, so it's just this block mapping. That's the thing I'm looking for. Right, so this is for each square. That's the vector. I have a vector of blocks. Okay, so block mapping. So this is just an unsigned. So this will be divided by size and modulo size. And I want to iterate over the blocks. And for each block, I actually want to go over all the nodes. I guess the squares. So b dot I guess I could actually do it differently. So I don't need to do that exactly. I can do just the number positions, because I do know that this particular node only has 2 different numbers in it. So right. Is there an easy way for me to get the numbers out of the square? I'm not sure. I don't think I built that kind of convenience API. Okay, let's just make this look simple. Right, so we go over all the squares, and if S is different from data n. So if this isn't the same square we are like triggering the search for, well, actually, if it's the same, let's just continue. So if it's different, we want to insert weaklings between this square, which would be just n, and s minus data 0. So the position of this square in the array, and the same thing the other way around. Oh, but we don't want to do it every time, right? We want to do it we want to do it under 2 conditions. So if s count possible is not 2, then we just skip over. So if this square doesn't have only two possibilities, then it cannot be part of this chain, so we just ignore it. And also this has to share one of the numbers, so yeah, we need to get the numbers that are actually possible here. So basically I don't have a convenient way to do that, damn it. I guess I can just do this. So unsigned next equals 0. So while data and dot next equal, okay. So while this is not 0, then we do this, okay. So if not is possible, then just continue. Okay. But this might not be enough, I'm just realizing. Because if I just build it this way, this will not ensure that I'm chaining the numbers correctly, I don't think. Yes. So what I actually want... Okay, I don't think I actually need this function at all then. Because what I actually want to do is just build the chains for all the numbers and then just search over that. Yes, okay. So it's... yeah. So... yeah, okay, we can still do it for one specific number. Hello and welcome to the stream. And yes, compiled languages are definitely the best. Okay, so let's generate the graphs for every number. Okay, so this will be... I should really pre-compute this outside, but for now this will work fine. So let's just get a vector of these and let's just put them inside. And by the way, if you have any questions, feel free to ask. Okay. So I do the get chains for this number. I think I'm on C++ 17-ish. It's a little bit tricky because like I'm using a pretty weird setup. So this is on Windows with Windows subsystem for Linux. So this is technically running the fresh Ubuntu version, which I think fully supports C++ 17. I can actually switch between GCC and Clang. So with Clang, I think I can kind of compile it with C++ 20, but the support is still not really there. There's a bunch of things missing. But yeah, basically this is CMake, so what I can do is something I have Clang. Okay, I only have Clang 10 here, so I can do something like this: cc Clang, cxx Clang ++10, and then CMake. Okay, I might need to delete some files because it's stuck taking it out of the cache with GCC. But basically, yes, I can switch over between Clang and GCC. But the problem is, since this is the Windows subsystem for Linux, when I was running benchmarks, it has some weird issues. And this is like running a weird cross-compiled kernel that's kind of forwarding things into the Windows kernel for all the, syscalls. So it gets really messy and weird. So I also have a... Yes. So this is the WSL2, because with WSL1 you cannot actually use the latest Ubuntu. But for example, perf is just completely messed up. I wasn't able to get perf working. So for that, I actually have like a terminal to a remote machine where I can just run stuff. But the problem is, this one is actually an older version of Ubuntu. So unfortunately, yeah, the C++ standard situation is still a little bit messed up for me. So this one is just... So basically, I kind of have this loop where I write code, then once everything works, I start looking at the performance. So basically what I just do, I upload the code to GitHub and then just pull it on the remote machine. There isn't anything more fancy. Locally with WSL, like everything just works as, normal. You just compile, things compile, run, there isn't basically anything special. It just all works seamlessly. Yeah. I think you can also do the same with like SSH, but it was definitely more flaky than the WSL locally. Like that's working very nicely. Like that's one thing I definitely am quite happy with. Okay. So we want to modify this depth first search, basically. Oops. Okay. So it will not get one graph, it will get a vector of graphs. In this case, we really don't care about the length. this function might still be the same. I'm not quite sure. And there's no weak, strong relationship in this case. So okay, we want to call. Oh, but we will definitely have the number. So the terminal check will basically be if path at path.size -1 oh, but we need to look into the. Yeah, okay, so this needs now more information because it needs to actually look into the puzzle. I cannot just make it purely on the graph, I don't think. Because what I actually want is a path that starts and ends with the same number. So how do I do that? Okay, let's make this part of yeah, okay, let's make this part of the Sudoku class. Because then it gets access, basically by default gets access to all the data. Sure, so let's just do that. Okay. Come on. Right. Okay. So then basically the check I want to do is whether the square at these coordinates, well, actually just like that, has this number as a possibility. Yes. And ooh, okay, it's not that easy actually. Let's go back to this. So it's not enough that the n square has the number as a possibility. We also had to have arrived on an edge that it's not for that number. But that's kind of an information I'm not really storing, I don't think. Yeah, I'm basically just storing the path, so I would say, you know, this node, this node, this node, this node. Okay. Well, the is possible is definitely a requirement, so I can just make it if it's not possible, I don't care. Then just like some intermediate step on the path. but also yeah, I think I need to have something like the source number, as in basically the last edge I traversed, what number did that edge belong to? So this would be like, and source number is not number. Well, I guess I want to check that first and then check the other branch, because this is a much easier check. Okay. Right, so if this is the case, then I have a chain. Yes. And I guess then I just call the callback, right? Yeah, and to return. Does it make sense to like... No, I don't think it makes sense to like continue in the chain, because if you would continue in the chain, like there also has to be, and then we would successfully create another chain, like a continuation of the chain. But then obviously the continuation itself would be a chain as well. So we can just end here, and then inherently we will find the other chain like somewhere in the search. So we can just return, yes. So, okay. So that's the terminal case. Okay, so the last node that we visited is still this. Okay, that's fine. So, right, and we know the source number. So we definitely only care about the weaklings. That's for sure. But basically the links we want to look at are the weak links for the other number in this node. Am I saying that right? So, okay, we start here. So the source, yes, okay, so let's say we start here. So this would be in a case where we are searching for chains for the number 3. We pick this square as the starting square. So the first element in the path will be this square, and the source number will be 9 because that's the other number that's with the 3. What we want to do, we want to look at all the weak links for number 9 from this square, right? So, yes, okay. Oops. So we want to look at G source number -1 because it's a vector, so it's 0 based, weaklings equal range for this node. So number 9 for this node, right? So that will basically tell us that there's a weakling to this square, okay. Okay, so we go over the range. That's still the same thing, that's fine. Yeah, we still definitely want to skip things that we have already visited. That's not changing. But here we actually want to put the logic that's checking that this square only has 2 possibilities, right? So if data dot data at so I dot second is the new square, count possible is not 2. That's not okay, so in that case that's not where we want to be looking at. So this would just be continue. If it has 2 possibilities, then it can be part of the chain. So then we just put it in and we call the traverse with the same graph, the same callback, the same path, the same number, but now now the source number will be the other number in the square where we are going. Right. So actually this should be this because, yeah, I'm kind of inverted the logic there. And this is a thing I need to still figure out. So, okay, I need to figure out, so here, what is the other number in the square that's not equal source number? Right. So while next equals data I second dot next next, right? So while this is the same as the source number, okay, so this will either stop on the first call if the basically if the other number in the square is lower than the source number, or on the second call if it is actually higher. We should never have a situation that basically if next equals 0, then there's something completely broken in the code. Right. So now I know that next is the source number. number next. Okay. Is this all making sense? So let's see. So again, I start here. If I'm triggering this from number 3, then the first next number will be 9. So then I'm looking for the neighbors of the number 9. I find this square. Next number becomes 8, right? Then I'm looking for neighbors for the 8, which would be this one and this one, for example. So let's say it's the first thing we try to go here. If we do that, then the next number will be 2. Then, yes, okay. So actually I don't want to call it source number, I want to call it next number. And I think I can actually remove this condition completely because that's kind of guaranteed by the way I insert things into the path. Okay. Right, so the only thing I'm missing now is the only thing I think I'm missing now is the first step. So it was this function, right? So it needs to get right. Okay. Oh, this is still wrong, damn it. Because this needs to be a vector. Okay, so what this function has to do is it needs to go over yes, over all the nodes for g number -1. And if the node has 2 possibilities, yeah. So if n data n count possible equals 2, then we want to trigger the search. And it will be this one, so it will be with the path, with the number, and oh, here we need to figure out what's the other number. Okay, so I need this magic here again. Next, right. Right. path next. Not I.second, this will be just n. I think that's correct. So, okay, what's the pruning method then? Is it still the same? So the numbers seen from both of the sides of the chain. Yes, that's still the same. So if I go here, so in this case, basically we have 3 over here and 3 over here and here and what was it, here and here, right? So this one sees these squares and this one sees these squares, and that overlaps in here obviously, well, here as well, and yeah, I guess here and here as well. Yeah. Okay. So yes, that's actually the same logic as the previous one. So so I can just copy this one. Prune number seen from path. Number, yes, okay, that makes sense. And what I want to do is then just call the DFS traverse similar to this. So DFS traverse graphs, not the length, but the callback, the number, and I guess that's it. Yes. Okay. Let's see if this works. So let's quickly write a small test. Sudoku test. Okay. Okay, so I think this we will have to craft a little bit more carefully. I guess we only care about the numbers that are actually involved in the chaining, I guess. So if I would just remove 2, 3, 8, 9 out of this puzzle and just reconstruct this kind of thing, let's see. So this would be the XY chains, test A. So I want to remove, what did I say, 2, 3, 8 and 9, okay. So 2, 3, 8 and 9. Okay, and I guess I want to do the same in here. Okay, so now I need to be really careful. So okay, so in row 1, position 3, I need to add a 3. Position 4, I need to add a 2. Position 5, I need to add 2 and 3. And then on position 8, I want to add 3 as well. Then here it's very similar, so I can just copy paste. So on position 3, that will be a 3. On position 4, I'm not doing anything. Position 5, I'm adding a 3 and an 8. Oops, and here I already made a mistake, right? Then position 7 will be a 3. Okay. There's nothing in this row. Okay, so in row, oopsie daisy, I didn't update the rows. Okay. Yes, okay. So, oops. On the row 4, position 3, there's an 8 and a 9. Then position 4 is a 9. Position 5 is a 2 and an 8. Then nothing on the next row. This row, so test row 6, position 3, I need to add a 3. I need to add a 9. Yes, then position 4, I need to add a 9. Position 5, I need to add a 3. And then I have 2 more 3s on row 7, position 7 and 8. Cool, okay. So that would be this test case. So what I expect from this, code, replace, where is it? Edit, find, replace, test, expect. Okay, so what I expect is that these 2 3s disappear, so that's column 3 on the first 2 rows, so this and this, and then column 5 on row 6, 6, 5, right. So this all goes away, and I do solve XY chains with number 3. Okay, let's see if by some miracle this is actually working. Okay, so this thing is now complaining that it doesn't see the DFS traverse. Which is weird because it should see it. I think I have accidentally hidden these now. So what can I do? Sure, let's just make everything a private member also of this class. Doesn't particularly matter. Okay. Undefined reference. Yes, because I forgot to prefix these. Right. Okay, yeah, stuff is not working correctly. What the heck? This is a bit curious. So, because of course I forgot to do the replace here. Yes, replace all. Yes, okay, do it. Okay, so at row 1, position 3, there is still a 3 in there. Okay, so this didn't actually... Okay. So time to debug, because this is actually not working. Which, I mean, is actually pretty good to know. Okay, let's breakpoint here. Right. So I need a calculator. 12 divided by 9 is sure. So 12. What the heck is this? I want probably not the scientific one. Okay, 12. Is this actually doing? Yes, okay, so this actually works. Okay, so this is row 1, 3. Okay, so this is a chain starting from this number. This one shouldn't really do anything. We have 14. Shoot. Okay. Because I did it wrong. What I actually want to do... Oh, this is hard to test, damn it. Yeah, the problem is now the squares have more possibilities than 2. I guess what I actually want to do is ij dot set reset to empty. Yes, I basically want to erase everything out of this square. Okay. So now it's actually working. Okay. So I guess let's just do like random change somewhere. Okay, it's failing. Okay, cool. So maybe this is actually working. So okay, let's first of all just rerun this, just so I have the fresh number of how many puzzles we actually solve out of the first 100,000. Okay, so out of the first 100,000 we solve this many, right? Oh, why is the font so incredibly tiny? Okay. So now if I just chuck the solve XY chains somewhere into the solver, let's see what happens. Where do I want to put it? I think somewhere pretty deep, because this is a pretty expensive thing to run. Finfish exchange. Okay, so I guess somewhere here. So yes, well, maybe just after the exchange. Okay, so I want to run this for every number, and this I will need to optimize this, because the way it's written now, it basically will regenerate the same graphs over and over, which is really silly. But I just want to see if this actually does help, because for the last bit I have been completely stuck. I mean, not completely stuck, but yeah, the power of my solving techniques have been kind of running into issues. So XY chains, I can't spell as usual. Then I need to change this. Right, X chains like that, and XY chains initialize to 0. Plus equals operator. Okay. And on the output, I guess, so just print it here. Okay. So let's see what happens. No, well, oh no, stats.xy chains, yes, okay. No, we are completely screwing up the puzzles. That's bad. Okay. So it works on the test, but it doesn't work properly. Well, okay, to be fair, we are not screwing up all the puzzles. We are screwing up quite a few puzzles, though. Okay, let's think about this. What could be going wrong here? Actually, let's just... I wonder if it actually does find the correct chain, because I'm not really testing for that. So let's go in here. Basically, when this function should be only called in the test once, I think. So let's go back to the test. Well, I guess debug. Okay, so what's the path that I have? So the path is calculator, right? So 73 modulo 3 is 1. Not modulo. What am I doing? 73 modulo 9. It's also 1, obviously, because. No, not obviously. Yes, obviously. Wait, the first element is 8-1? That doesn't sound correct. 8-1. What? I mean, 8-1 even doesn't even have a 3. What? What? Wait, what, for number 8? But 8-1 shouldn't even have an 8. What the heck is happening here? Yeah, I'm not putting 8 into 8-1 anywhere here. What the heck? And I mean, wait, am I running the correct thing even? I want the Sudoku test, right? How is this even called with number 8? I mean, I'm calling it with number 3. What the heck? Well, this is interesting. It is to solve XY chains. Path number. What the heck? Oh, wait a second. Was the compiler being annoyingly smart on me? I think it was. Yeah. Oh, that bastard. So what's actually happening? Yeah. Because this function is the same. It actually got optimized. Oh, that's annoying. Okay, I need to switch to debug then, because okay, I think I can do it here. So I want to be in debug. Okay. So I think now that I'm in debug, it shouldn't, and I just noticed a bunch of warnings that I didn't notice before. Okay, so now we are, okay, I don't care about that breakpoint in particular, but now we are getting called from solve XY chains. Okay, so now it didn't get really optimized. Okay. Yeah, because it was the problem that this function, this lambda had the same code in all the places. And because of that, the compiler was being smart and just optimized it into a single lambda. But then, of course, if I only care about this one particular case, it's kind of hard to set the correct breakpoint. Okay. So the path that we have is 14. Let's see. So 14 would be 14. Obviously divided by 9 is 1, but what I care about is 14 modulo 9. That would be 5, right? So that's 1 5 0 1 2 3 4 5. Okay, so that's it. The chain is starting here, so that's making sense. And I guess we can actually follow the chain here, right? So it starts here with the DFS traverse number 3. So then we are here. And next is 2. Okay, so number is 3, next is 2. So it's this space, right? Then here, next is 8. So we are here. It's here. Next is 9. Okay. Then next should be 3. Yes. And then we call the, okay. So this did find the correct path. But there seems to be some sort of problem where we are overly aggressive in some cases, and I'm not quite sure. The only restriction beside the obvious necessities for the links is that the XY chain starts and ends with a strong link on the same digit. Yes. As with exchange, this proves I wonder, is there a case where the chain is too short and we would basically remove the possibilities too aggressively? How would it look like? Let's just... So I guess that would be something like we have a 3 and a 4 here. Then I guess like a 4 and a 5. Well, actually, okay, so can we have like a 3 and a 4 here again? So this would be like a mini chain, but I guess this is also a pair. So all this should remove is just the numbers from this row. All the other 3s from this row. I mean, that's fine, right? Like, that doesn't really break anything. So if we have a 4 5 and then a 5 3, that's still fine, because basically that needs to remove the 3 from here. Yeah, because if this was a 3, then it removes the 3 from both of these, and then this becomes 4 and a 5, and this can be nothing. So I'm not 100% sure where this could break. I guess we can have a look at the specific puzzle that breaks. So okay, let's just quickly run it. No, not Sudoku test. What I want is the main binary, right? So line 118. Okay, so let's see. Let's run it with edit configuration 117 and 1. Is that how I set up the offsets? I think so. Yes, incorrectly solved puzzle at line 1. Okay. Yes. So now okay, now I guess I can have a look at what the heck is happening in the callback. So let's run debug. So okay, on number 1, the path is this, and I guess let's just quickly do a sanity check. So what I want to look at is basically this dot data 32 dot count possible. Oops. Okay, so this is fine. 41 is also fine. 14, this is also fine. 77 is also fine. Okay. Now, I guess let's just double check if the endpoints is possible 1. Okay, that's fine. And 77. Okay, that's also fine. And let's just double check if the midpoints don't have it as possible. So this is false. And 14 is false. Okay, so this does look like a valid chain. Right. I created a method for checking. What the heck was it called? Oh, has conflict, right. So I guess what I want to see is new watch. This has conflict. Okay, so right now everything is still fine. Oops. Okay, so let's step over this. Okay, so we are still okay. So the second time this is called on number 1. Ooh, okay, I'm getting the feeling that I know what's happening. It's again we keep kind of destroying the puzzle beneath our hands because I just removed some numbers out of the puzzle. And now I'm still trying to solve it. So actually what I should be doing is basically completely bail out on the first successful find. Yeah, because the problem is, what can happen now is I still have the old graph, but I have changed the puzzle, and there can be basically a disjoint now between the puzzle and the graph. And we had the same problem with the fish rules. Sorry, not the fish rules, the finned fish rules, yes. Okay, so how do I deal with this? Okay, can I guess this would be a good place to fix it in a systematic way, because I didn't do that last time. Last time I didn't fix it in a systematic way. I kind of just hacked around it by saying, oh, like, let's just take the first result and that's it, and don't do anything more. The systematic solution would actually be basically make the changes in a copy of the puzzle, then the pruning techniques are still being applied onto the original puzzle, and we don't break any assumptions that way. I mean, the problem with that, of course, is we need to make a copy of the puzzle, but is that really a problem? Okay, in that case, okay, so in that case, I think it really makes sense to have the solve XY chains not be parameterized by a number. So what I do, I grab all the graphs, I make a copy of the puzzle, I let it run. The pruning will happen on the copy, not on the source, and then I just swap it after I have done all the changes. Yeah, and we can then basically do the same thing for the other rules where we had this problem, because I mean that will even allow us to be more efficient, because we don't have to basically bail out on the first change. Yeah, okay, so let's try to build the support for this. So I kind of want to have okay, I will need to be super careful about this, because yes, okay, so the swap will not be a simple swap. What I actually need to make sure that I don't move the pointers, because the way I have my Sudoku puzzle setup, it's very sensitive towards like things positioned in memory, because what I do is the block checkers actually have pointers to the squares, and then like all these things like the block mappings and whatnot have pointers to the block checkers. So I really need to make sure that I don't change the pointers. I really need to make copy of the data itself and then just overwrite the data back. Okay, so right. I will have methods make copy and swap copy. And okay, so make copy will be very simple. That one can just do data copy equals data, because here we don't care about the pointers. The important pointers are the pointers inside of data. So this one will need to be super careful. So this one we will need to do unsigned I equals 0 less than size times size, and what we need to do here is data I equals data copy I, right? And this way we will not screw up the memory positions. So in here we build the graphs, we make a copy, we do all this, and then we swap copy. Right. So now the prune actually needs to be smarter, or I guess I need a second one. Seen from in, well, okay, let's just copy this entire thing. And let's just call it prune numbers seen from in copy. So this will actually not touch the original. So all the checks will be still done on the original. The only thing I want to really change is this. So get square. Okay. So this gives me the square. Okay, so this gives me the square. What I need to do now, I need to figure out its position. So the position is data 0, 2 prune minus data 0 is the position, and what I want to do, data copy at the position minus equals number, right? Okay, so let's just quickly check. Okay, right, this needs to be a pointer. Let's just quickly check, is this the only place where we are removing stuff? I think it is. There's just a bunch of skipping and stuff otherwise. Right. And I guess this needs to be added in the header as a method. In copy. So then inside of here I need to indeed call the in copy, and yes, I wanted to change this so it does take the number. So this would just be for unsigned number equals 1, number less than equal size, number plus plus. But actually I want to make the copy for all the numbers and then swap it at the very end. Yes. Right, okay, like this. Well, I guess this can be outside. Oh, it cannot be because it's parameterized by number, of course. Needs to be here. Okay. Right. So let's quickly oh, I changed this. So I need to, yeah, okay. This doesn't build now, of course. Okay, and the solver. XY chains. Yeah, just do XY chains without anything special. Right. Cool, so now we are not breaking this puzzle, which is great. There were some warnings that I wanted to fix. In file what? Canary expects 0 arguments, but 1 provided. Oh, in the test, right? That's definitely possible. Where the heck is it? Ah, yes. That's definitely a bug. Okay. Build, rebuild. Progress bar conversion from. Okay, yes, this was the thing I wanted to. Yeah, static cast CEST. Okay, and then conversion from CEST to int. Yeah. Yeah, okay, I will fix that later. Okay, so let's run if this still passes. Okay. So I guess what we want to go now is go back to running the 100,000 puzzles. Okay, let's see. Ooh, that might be a serious slowdown. Okay, well, actually, I should just call memcopy because the squares are just plain old data types. Well, not plain, what do you call it? Oh, damn it, there's like the word for that in C++. Not trivial, but... Oh shoot. Is it trivial? Is trivial? Provides member quick trivial type. Is the, yeah, one of these, like I think trivially copyable. Scar types, trivially copyable classes. Yeah, so I think our squares should be trivially copyable. So I think I should just be able to do like a mem copy instead of the loop, which might be faster. Yeah, man, okay, this is really slow. Ugh, that's not nice. Yeah, it might be better to just bail out on the first match then. Don't know. I will need to do some. I think that's a good topic for next week. Look at the performance again. Yeah, because one of the issues with this, the XY chains in particular, is because they're bounded by the size, like by obvious number of candidates that can be in the chain, right? But like for all intents and purposes, they are basically unbounded. Like we are just looking for paths in a graph, and we don't really have a good cutoff. The only cutoff is like you cannot repeat a square in the graph, like obviously, and it needs to end with the same number, but there's not really a cutoff. That's just like once I find a path, I check if it ends with the same number. Yeah. Not amazing. And yes, this is pretty slow. Okay, I will use the opportunity to have a very short break. Be right back. Oh, even this is broken. What the heck? Everything is broken. Yeah, okay, I'm back. So stuff finished, okay. We did have a bunch of XY chains, and okay. That did help significantly. Like we just jumped by quite a lot. even though it's like super slow, this was a very good technique apparently. So that managed to solve 99846 minus 98965, 881 extra puzzles, and we are only missing from the first 100,000 99846 only 154 puzzles. Okay, that's a very powerful technique apparently. Okay. Well, I might suffer through the soulness then. if it's actually this powerful. Okay. I must admit that's a little bit unexpected, honestly. So, well, the question now is, what the heck do I do? Because I was kind of expecting this to like help a little bit, but not by this much. Okay, so I can browse the 846. So 154 puzzles. So what I'm actually thinking might be a good approach at this point is straight up just hunt down what exactly are the methods that these puzzles need, because there's so few of them that I'm not able to solve that actually might be the correct thing to do. But okay, let's think about this. So I mean, since this is so powerful, I actually wonder if I should just look at the performance at this point and try to fix that. Like this is making a massive impact. Okay. Well, first of all, let's just do some very basic performance tuning. So first of all, I will just run this. Yeah, let's just run it on the first 10,000. And yeah, I'm still not sure, like, where does this like second? Yeah, some of these are pretty slow. It's quite interesting. The progress bar speeds up and slows down as it's running into hard puzzles. Okay, so that was 26 seconds. So, oh, this I'm actually running in debug mode. That's maybe why it's so slow. But let's. Okay, so first of all, let's just switch it off debug because that's silly. I should definitely be running it in production mode. Well, actually, maybe not like that. Oops. Yes, stop. Please stop. Let's just build it. Okay. Okay, that's that's significantly better. Okay, so this is 2.5 seconds runtime, right? Let's, although I kind of suspect this is already happening, let's just do mem copy into data. Yes, much faster. That's the difference between debug mode and release mode. Data copy. Okay, how the heck does this function work again? I haven't used memcopy in ages. And where is it actually defined? It's actually memcpi, not... yeah, okay. Destination source count, right. So, CPI. Destination is data, source is data copy, and count is size times size of square. Okay, and this is in there. Okay, let's see if this does anything at all. I kind of suspect this was already happening. Oh, and I'm being stupid. So this should be like that. Well, actually like that. So data. That's a very good question. I'm actually not sure, to be brutally honest. It should be running with -03, but I must admit I'm not super sure. Okay, let's see if this did anything to anything. Yeah, okay, so there's no difference. So this was already happening, so I will just revert this because we don't have to do that. Okay. It can, okay. Oh, O2, okay. So I guess, damn, I don't know where that's actually defined. Yeah. Like once the solver is actually working, before I move on to the next step, which would be the UI to actually play with it more, I definitely need to fix my CMake files because this is such a insane mess right now. I guess standard project settings. Maybe not. Am I mentioning? CMake -03. Oh, about this find something. Default release build flux. Yeah, but the problem is that gets tricky because if I just do set CXX flags, then it will apply to all the build modes. What I actually want to do is just change it for release. No, it's not the derailment, but I can set it per build type. Wait a second. This website was claiming something. No. Probably not. What the heck? Ah. Okay. Well, let's see if this does something. So that would go in here, I guess. And this would be rel with tab info, right? And I guess also release. Right. Build. Maybe I need to call CMake again. Now it's building with warnings as errors again. Oh, damn it. It's another thing I need to figure out what the problem there actually is. Well, not with this I know, but this one with the virtual methods, I still don't understand exactly what's happening here. Right. Did it actually variables equals 1? Oh, but now it's okay. Let's just delete the binary. Yeah, okay, seems to do stuff correctly. So let's see if this makes any difference. Yeah, maybe there's a slight improvement. Yeah, maybe not. Who knows? The timings look like maybe sometimes it's a bit faster, but yeah. Guess this is not a big enough dataset for it to show up. Okay, so damn, like, I'm so close to being able to solve all the puzzles. So okay, yeah. Should I implement this? Yeah, definitely. Like that's why the release with the debug info is usually good, but then you have the situations like that was happening to me where like the lambdas were all built into like a single thing, and then like if you set the breakpoint, it triggers on things that make no sense because it's being called from like completely different places. Okay. Yeah, yes, so this solver is not using any backtracking at all, indeed. It's just pure forward solving, removing possibilities from the puzzle. There's no guessing. And yes, like if I did use backtracking, I wouldn't be on episode 17, 18, whatever, 18, yes. Because like backtracking solver for Sudoku, you can write in like 20 minutes. maybe even less, who knows. But yes, so if you actually want to solve it by logic, it's way more complicated. But it's also a lot more fun. And the benefit of that is, one thing I want to actually use this for is to actually generate puzzles. And when you want to do that, with the backtracking solver, it's kind of hard to tell what the difficulty of the puzzle is. With this kind of solver, you can very easily go by just, okay, like don't use these kind of solving techniques when you are generating the puzzle. So it's possible. So I have a big data set of 9 million puzzles. So I'm using that one to like test stuff, and I just, you know, have parameters where I can say like run on the first 10,000 or first 100,000 or something. But if you have the text file, so the tricky part is, do you also have the solutions? Or you just have the inputs? Because if you have the solutions, then if you can just post the text file somewhere, that would be nice. If you only have the inputs, then I can still try to put them into my solver and see what happens, but I cannot really, you know, verify if the solutions are actually correct. I mean, I can verify it like visually, but yeah. Right. Damn it. I don't. I'm not super fond of like implementing these like super generic chains, because they are like super strong in solving puzzles, and like this is almost like guessing. It's kind of, yeah. Well, again, like if you have the input, just, you know, post it somewhere and I can try. It will be fun to see what happens. Okay. Well, I'm thinking, let's just have a peek through the like the other things. So there's also like coloring and stuff. Yeah, I don't know if this is super useful. I mean, this is basically like chains. You are just like coloring stuff and then finding opposite colors. Yeah, no, not super sure about that. I'm still not using the uniqueness thing. Yeah, so if you just want to have a fast solver and you don't care about the solver making guesses, the best approach, honestly, is just have a very simple pruning technique where you just remove the singles out of all the rows, columns, and blocks, basically, and then just use a backtracking solver. If you do that, you can solve most puzzles super fast. Because the moment like you catch on like one number, it just like the pruning is super fast. But yes, for very, very complicated puzzles that have like only few singles put in, I can imagine that that would be still slow. But again, like if you have the puzzles, I can definitely try and solve them and see what stuff happens. What the hell is this? Like, I would really like to see a human do this to a puzzle. Like, this is insane. Like, I cannot even see what the hell is happening. Okay, let's see. Okay, so these are just the inputs. Okay, cool. Well, So I will need to modify the code a little bit, because right now my code kind of assumes that it also gets the solution, but I mean, it shouldn't be that hard. Okay, well, let's just save page S. Okay. Actually, I can make it easier by just doing this. Okay, cool. So how do I do this? So solve one Sudoku. So let's just copy this. Oops. And let's just call it solve one Sudoku without solution. Yeah, I don't really, well, so it gets tricky because like there are some techniques that are just like not guessing, but they basically solve all puzzles. It's where the heck is it? So by the way, if you're interested in this, this is that's part what? Oh, I think my local chat is not showing the correct smileys or something, or oh, you mean the brute force one? Yes, okay. So I think, was it this one? So there's like a generic technique for like basically propagating stuff. It was either this one or something in the chains, where basically you can solve any puzzle, but it kind of reaches the point where like you might as well be guessing, because you're basically finding contradictions, like logical contradictions in the puzzle, which, I mean, like, I'm still trying to make it work kind of like a human. Okay, so if we don't have a solution, we don't expect to get the comma. Then okay, so not this, then we solve this. Yes, so as how do I actually say your name? Abal? It's really hard to read the letters. Okay, yes. So as Abal already said, that I actually did basic backtracking solver in the first episode, and all the VODs are actually on YouTube. So if you just jump to my YouTube, you can find that. I wouldn't like super recommend that. But also what you could do is, let me just quickly give you the link. So if you just dig through the history on this, in the first commits, there's a simple backtracking solver that just works. Right, so solver solve. I guess if maybe not correct. Okay, I cannot check if it's correct, so this goes away. Put clear. Okay. is that all then? So, okay, I don't have the output. Yes. And I love it. It's a great database of Sudoku puzzles. It's absolutely amazing. Right. I think that should work. So basically what I just need to do is yes, I could do that. That's true, but yeah. Solve one sudo. Okay, so need to copy this one as well. Run benchmark, no solutions. Open file, global stats, sequence. Okay, I don't want to actually do the sequence here. Line equals 0. Solve one Sudoku without solution, right? Align. I don't really need this. Benchmark result solved. Incorrect will be nothing, that doesn't really matter. Global stats, okay. Right. Am I actually correctly updating the solved? Yes, if so, okay, cool. So then I just need to add some quick way to do this. Okay, let's just do it the very stupid way. So if I get 3 arguments, then just return run benchmark no solutions argv1. Right. Okay. So build it. Unused parameter, I don't care, that's fine. Okay, so if I didn't screw up anything, I should be able to run it now. Return function to check if a given answer is a valid solution for a given puzzle. No. Well, that's definitely a thing I will need to write at some point. So, because I have this big database of puzzles, basically I have the solution, so I don't really need to, double check. Okay, let's see. Oh, I should have added the yeah, I should have added the progress bar, because now I don't know what the heck is happening. Yeah, again, like for sanity checking, I just use the dataset because the dataset has the solutions. And I definitely had phases where my solver was actually breaking puzzles. It would basically solve the puzzles incorrectly. So I check if the solution matches the solution in the dataset, but I don't like try to solve it with, a backtracking solver or something. Okay, so the result was that my solver can solve. What's the ratio here? 47813 divided by 4. Oops. Divided by 49151. Damn it! I'm in the in the programmer calculator, which is doing integer arithmetics. 4915. Okay. So 97% of the puzzles it can solve. And this is with the caveat that I'm not checking if the solutions are correct. But so far, like my solver was pretty good at doing stuff. So, but it's just like looking at the numbers of like what rules got applied. It definitely got a good exercise out of these puzzles. Yeah, it's like triggering on the very hard solving techniques a lot. So by the way, it's like this is one of the nice things about like since I have a bunch of the different solving techniques, I basically get these stats that tell me, you know, this is accumulated across all the puzzles, but I can basically look at it for one puzzle. It tells me basically the difficulty of the puzzle, because if I just quickly jump to the solver for you, so how my solver actually looks like is basically like this. So it tries to solve the singles. If that doesn't help, it basically, you know, does a technique, then it checks if the technique did anything to the puzzle. So it basically is try to solve singles, did it help? If it didn't, then try to solve you know, the like, what do you call it, doubles. Yes. If did it help? If not, then try to solve block intersections. Did it help? If not, then try to solve triples. Then did it help? No, then go to solving X-wing. If that didn't help, then go to solving X-chains with length 4. If that didn't help, go to solving you know, groups of 4 and whatnot. And it basically like ramps up. But that way, basically, if there is like a simple technique to advance the puzzle, it will always use that first. And only if the simple techniques don't do anything, it goes to like the harder and harder techniques. I'm pretty sure right now the ordering of things in this file isn't the best. I need to kind of revisit that and rethink, you know, what's the actual ranking of these techniques. But for the most part, this works really well. Basically tells you that, like, you know, if you see, oh, it actually went to like X chains of size 4,600 times, well, that one is pretty deep in the stack. So these are indeed very hard puzzles. Yeah, thanks. Like, this is definitely nice. And these are definitely hard puzzles because on the big data set, like my unsolved rate is like around 1%, below 1% at this point. But on this one, it's, you know, 3%. So this is definitely a hard data set for sure. Okay. Well, okay, one thing I could do actually is, but I actually might need to do that offline. So one of the apps I have on my phone, it's called Sudoku. It's this one. And this one actually has like a very nice hint system. So if you basically, like, I can basically take a puzzle that I cannot solve, put it in there, and then just basically press hint, and it will tell me what kind of like solving method would, you know, make the puzzle advance. Well, pretty much yes. So Smart Solver Solve basically tries to solve a puzzle, and it will basically loop until, you know, either the puzzle cannot be solved or is solved. Yeah, and it's basically just, you know, a bunch of calls into other parts of the code where it actually does stuff. Yeah, so yeah, that's something I'm definitely not doing now, and that's actually deliberate. So I don't want to multi-thread things because, well, first of all, the speed of a single puzzle is actually what I really care about, and that will always be pretty short. In general, once you start multi-threading things, it becomes super hard to reason about the performance. So, and honestly, like until now, running on the 9 million Sudoku puzzles dataset, like it was running for like 18 minutes before I introduced this new thing. And I haven't really double checked, what's the impact on the big dataset, but it's honestly pretty fast already. So I don't really feel the need to have it multi-threaded. So what one thing I want to do once this is basically finish solving the basic Sudokus, I actually want to build it into a service. So you would have a server running where you can send RPCs to the service and it will solve the Sudoku puzzles. And at that point, it's already multi-threaded because each of the requests is running in a separate thread. Oh, so this line right now doesn't do anything because again, so in the old data set, I always have the input to the puzzle and the solution. So I do check if the solution matches my solution. So there were definitely cases where my solver was actually broken and it was basically breaking puzzles. So this would be, non-zero. But your dataset doesn't have the solutions. So I mean, actually, the quick fix for me would be to just chuck this into a backtracking solver, generate the solutions, and just change the file so it has the solutions in it, right? And at that point, it's just like any other dataset for me. Right. Okay, so what should I do now? That's the question. Okay, one thing I'm right now. Okay, you made me curious, so I wonder if I just take like a random puzzle out of this. Okay, let's just take this one. Oops. No, that's not. I didn't really copy it, did it? Okay. So I want to see if this actually is in my big data set, which it could be. No, it isn't. Okay. So just a random check. So this one particular random puzzle is not in my dataset. Okay. Okay. Let's. Yeah. I mean, to be fair, I have no idea how the person that provides this dataset generated this puzzle or where he collected them from. There's like a smaller dataset that's complete garbage because all the puzzles in it are super simple. But this one actually has like really hard puzzles. Yeah, with basic Sudoku, yes, I think there was even some sort of mathematical proof. I don't remember if it was actually 17. Sudoku lowest number of digits. But they have never found the 16. Okay, so this was 2012. People are saying nobody was able to prove it. But I think I have seen like something about a proof. 17. No. Okay, yeah, so there is a proof. Yeah, okay, yeah, and I'm now on Wikipedia, and yeah, that also actually links to the proof. And it was confirmed by another guy. Okay. Yeah. But there are definitely Sudoku puzzles that, you know, don't actually have any numbers in them. But then you need different rule sets. So there's like chess Sudokus that have like either kings and knights in them. You can even have queens, like queen Sudoku, where is basically the nines are queens. Yeah, so I mean, right on Wikipedia it says like this guy found it through exhaustive computer search. So that means like he found all he basically tested all the 16, you know, size puzzles and less, I guess, and none of them were actually solvable. And I suspect that there will be like a link to the data set here of the 17 puzzles or something. Database, yeah, okay, so there's a database. So these are the symmetric ones. Yeah, I mean, Wikipedia is pretty good at like linking to stuff, so I'm sure there's a link to your dataset as well. Okay. So one thing I definitely want to try. The problem is I don't think I will be able to do it like so you can see it on stream, but I just want to print out one of the puzzles I cannot solve and see what kind of technique I need to implement for it to be solved. Yeah. Okay, so let's just edit the configurations. So let's just run on the first 10,000 puzzles again very quickly. Oh shoot, no, mistake, crap, what the heck is happening? Yeah, I forgot to switch the data set. Okay. Right. But what I want to do now is if I'm not able to solve the puzzle, I actually want to print it out. So that would be in here. So if I didn't solve it, right, else, let's just std standard error, and let's just print out I guess the only thing I can do is the line. At line number +1. Okay. Actually, I think this is not +1. I think this is actually line number as it is. Okay. So let's just quickly run it. Okay, so 663. Six is 3. Okay. So I think it's this one. Or I guess I can just, for verification, I can also print out the solution, because that I do have. And just to format everything nicely. Okay, let's do it again. Okay. What the heck? So it's not, it's line plus 2? What the heck? How am I'm counting the lines in a really weird way, apparently. Right, so it's this one that I cannot solve. So let's just copy it here. Nope, that's the wrong thing. Okay. So I wonder, is there online Sudoku Solver? Yeah, but I'm off by 2, which is the reason why I'm not sure what the heck is happening there. Okay, there's something here that I maybe can use. So let's try to input this thing into this, and let's see if this thing tells me something about this puzzle. So 1, 8, nothing. Okay, 1, 8, nothing, 3. Nothing. So nothing. Then the next line is 9, 3. Nothing. So that's 6. 1, 2, 3, 4, 5, 6. Then the next thing is an 8. Then a 7, then nothing, then a 2, nothing, and a 9, a 6, nothing, oops, a 1, nothing. Okay, damn it, I will need to format this a little bit because I'm really worried that I'm making mistakes. Oops. Okay. Okay, that's better. So that's fine. A 9, 3, then okay, I'm already off by 1 here. So 8, 7, nothing, yeah, whatever. This should be a 2, this is nothing, this should be a 9, this should be a 6. What happened? 8, 7, nothing, 2, nothing, 9, 6. What the heck? Did I screw up the number? Oh, I did. How did it line up? Yeah, my copy pasting skills apparently are not up to snuff. Okay, what the heck? 0, 1, 2, 3, 4, 5, 6, 7, 8. Did I copy this somehow wrong or something? Like I'm missing numbers. What the heck? Okay. Did I copy it correctly this time? Oops. Well. Okay, now it's correct. What the heck happened there? I have no idea. Okay. So back to this thing. 1 8 space space 3 space 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 9 3 blah blah blah. Okay. Ah, okay. Interesting. It's on the right. Okay, so are you saying I'm still missing the 0 or I hope I'm not anymore. Okay. Zero 7 6 1. Okay. Seven. Okay. Yes, and please, if you see some mistakes that I'm making, please tell me before I screw it up completely the second time. Yeah. Yeah, I might have just accidentally deleted it when I was like editing the text. 9 6 8 0 4. Okay, really wondering if this online solver will be able to deal with this puzzle. 4 5 0 6 0 5 3. Okay. So take step. It's still doing singles. "3D Medusa." What the heck is 3D Medusa? Okay, there's one thing that I'm not implementing. Okay, I don't want to click on it now because I don't want to scrub everything. But okay, what the heck is 3D Medusa? Simple coloring or simple chains into third dimension. Simple coloring looked for pairs in X rows. Three chains like is stuck on sync. This is good for tracking elimination. Oh my god. Okay. So this is like a weird multi-chain thing. Does... Okay, let's look for it. No. Coloring. No. Okay, so the Sudoku site doesn't mention Medusa by name. But I think it's... Yeah, that's like the one thing that... WXYZ wing. I think I'm not implementing this one explicitly, but this one might be implemented implicitly by some of the other rules. Okay, so let's go for this. Okay. What the heck? Oh geez, I think I will need to read this offline because this is... This is kind of complicated. Okay, XY chain, fine. 3D Medusa again, perfect. Okay. Yeah, so like, just looking at this, like, this is an insane. Okay, wait a second. So let's disable the 3D Medusa. I've actually restart. Can I? Oh shoot! It doesn't allow me to go back to the original. That's annoying. But okay, I guess I can go back to the original from this pretty quickly just by deleting stuff. Right. Real. Okay. Saved as a cookie. Reload? No. Yeah, no, the problem is that's reloading from the cookie. And I'm glad I didn't press that because I think it would reload the example. But yeah, I can, now I know that I can actually save it and do that. Right, 7, nothing, 2, nothing. Wait, this should be a 6. Nothing, oops. Okay. Nothing. So I'll go away. 7, 2. Okay. 8, 6 is fine. 6, 8, nothing. 4, nothing. 2, 4, nothing. And good. Okay, let's save this now. Okay. So now I disabled the Medusa. So let's see what happens. So it's doing XY chains. We can do that, that's fine. But it's again doing the XYZ wing. Okay. XY chain, okay. XY chain again. Okay. Yeah, I think it's done. Okay, so I think, well, okay, let's see if I disable the XYZ wing. Oh, it did? Might have just stepped over that. Okay. So I will pay a little bit more attention now. Pointing pairs, sure, okay, I do that, that's fine. Oh yes, unique rectangle. Yeah, okay, I don't have unique rectangle solver. I mean, it's pretty easy to implement. The problem is I didn't want to do that because like unique rectangle only works for symmetric puzzles, which is something like I kind of want to avoid techniques that are only applicable to basic Sudoku because I want to implement like, you know, other types of Sudoku as well. But I guess we can implement it and then just like turn it off. That would be a thing. I mean, unique rectangles are pretty simple, right? Okay, sure. Let's try that. So disable unique rectangles, and let's see what happens. Okay. Pointing pairs is fine. Aligned pair exclusion. Like, these are techniques I have never heard about. This is a nice site. Holy crap. So what the heck is this thing doing? Ah, okay. Any two cells that cannot see each other cannot duplicate the contents of any almost... What the heck? Almost log set they both entirely see and share candidate with. What? It's the simplest almost with size. G to G3. So 2, 5, yes, okay, so these are all the possibilities, yes. And we cannot pick the 2 and an 8 because, yes, that would interfere with this, yes. And 4 and 8 would basically get rid of this, okay. Ah. Okay, this is such a weird thing. So basically because... Yeah, because these two cells see both this and this. This cannot be an 8. Because these doubles see both have an 8 in them. That's so strange. Wow. Okay. I mean, it makes sense, but it's... Yeah. Wow, this is such a weird strategy. Like, I can see how it's powerful, but it's pretty weird. Huh. Okay. Yeah, I will kind of need to think about like what's my next steps, because I can keep implementing these like weird rules. And honestly, like at some point, I basically should be at this kind of stage. Like I should have all of this crap at some point, right? But what I also want to do, I want to support like a bunch of weird Sudokus. Like, for example, Jigsaw. Like, I think I should be able to support Jigsaw just like straight up. Because like all of these basic techniques, like I should have implemented them in a way that they also work in a Jigsaw Sudoku. Diagonal one, yep. What's Windoku? Windoku variant. Oh, okay. So it's just it's basically the same. It's just the blocks are distributed differently. Color Sudoku is the same idea. It's just distributed differently. But killer Sudokus get very interesting. Like this gets quite interesting. Yeah. So yes, there's many things I can do next. I need to think about it more, I think. Honestly, like at this point, one thing I really should do is actually work on the UI, like actually have an UI where I can basically do what I did here, basically, you know, come in, put in some numbers, then just click stuff and, you know, see what's happening. That would be, I think, the next step, honestly. But it gets tricky because I want to make it in a way that it also works with the other variants of Sudoku. Like for example, this one, the only thing that's like actually special here is the killer Sudoku. And honestly, if I just look at it, like this is not particularly nice. Like you basically have the sums on the side, and I actually want to have them in here. Like it should work more like the daily killer Sudoku, like this, where, you know, you have the numbers in the squares very nicely laid out. And then of course I want to support things like Thermos, Sudoku. Is there some... don't really want to open videos, but basically in here you have these thermometers where the numbers have to be increasing. I definitely want to support that, and there's like a bunch of other interesting variants. Like you can have sandwich Sudokus where you have like numbers on the side that tell you how many numbers are sandwiched between 1 and 9. Yeah, there's a bunch of interesting Sudoku variants. So yeah, I wanted to think about it before the next stream. Okay. which I guess means that for now I don't really have much to do anymore for today. Do you guys have any questions that I could explain? I'm not really guaranteeing that I will be able to explain stuff, but you know, if I can, I will try. Because if there are no questions, I think the thing I will do actually is to just run the big benchmark. Oh, and there was a thing I wanted to fix. Okay, so I will just do the small fixes then. Right. So I had these warnings here. Will be initialized after. Okay, yes, I have the wrong ordering here somewhere. So this needs to be last. Rebuild. Conversion. Okay, I know for sure that this is a positive number or a 0, so this is okay. Oh, didn't do that correctly. Okay, so this is expecting okay. Oops, no, don't run. That was a mistake. Rebuild. That's the thing I wanted to do. I guess these should all be integers. Yeah, there's no reason for this to be size t. It's just making things confusing. Okay. Okay. So conversion. Okay, so this should be an int, yes. Okay. Okay, here, then I can just use the count. Yeah, okay, now it's complaining that I'm downscaling an int64. Well, okay, why did I actually make this an int 64? That's kind of ridiculous. But I guess that's, yeah. Unused parameters. Okay, I guess this warning I don't really care that much about. Okay, so let's run it on the big dataset again. The thing I wanted to remove was this. And I guess, yeah, okay, so instead of this, damn it. I will not be able to fix it now. Okay. Let's just run it. Let's just end the stream with the final stats, because I'm actually interested in the results. Yeah, it's definitely running slower for sure. Oh wow. Okay, it's really getting stuck on the hard puzzles. Yeah. Okay, I think I will need to let this run offline, because this will take a long time to process. Yeah, it might be better to just in the XY chain don't do the copying, and let's just like basically bail out on the first match. Like if the moment we change something, just like run away. The problem is I would have to change the way I have it written right now. Actually, where do they have the XY chains in the list of things? So it's after swordfish, okay, but before jellyfish. Okay, interesting. Oh wow, they have Fint X-Wing at like the extreme category. That's interesting. Interesting. I will need to study this website for sure. Oh, I'm actually looking at the wrong type of Sudoku, but I don't think that changes much. Yeah. It's still basically hidden singles, naked pairs, triples. Oh wait, they're putting quads very early. Okay. Box line reduction. Yeah, okay. Now I need to study this carefully. Yeah, we are just about to reach 1 million, so basically 9 times the time it was running until now. Still. Yeah, this is the copies are expensive. Very expensive. Wow. Like when it runs into hard puzzles, it basically just stops for a bit. It's kind of funny. Okay then. I think I will just wrap up here and then upload the stats to the repo. So thanks a lot for watching. And I do stream every Saturday and Sunday at the same time, starting 2:30 p.m. Central European time, and then going, for 3 to 4 hours. And yeah, hopefully I will see you guys at some point again. Have a nice remainder of the weekend. See you.